Thank you everyone for joining the DBA-VUG September meeting. This is our second meeting of the month, and welcome everyone. Stop this. Okay. As you can see on the screen, we have a X handle or Twitter, old Twitter. We have our meetup, also have a LinkedIn group, and have an email address. So if you have any feedback for us, you want to speak at our user group, you have a suggestion, please do send us a note into that email address. We do monitor that all the time and we'll respond to you. dba-vug@outlook.com. We meet twice a month. First, second Tuesday we meet noon Eastern time, and the fourth Wednesday, sorry, like today, we meet on the noon Pacific time. To be fair to our friends from West Coast, so they are always not suffering. So we alternate these 2 times in a month. We do have a YouTube channel, like today's meeting is being recorded. Whenever speakers allow us, we do record the meetings and we put it in our YouTube channel. So today's recording will be available probably by the weekend. So do subscribe to that channel so you know whenever there are new videos uploaded. And these are a couple of future sessions coming. As you can see, we take 2 off in a year. One is for Thanksgiving and one is during the holidays. And I already started booking speaker for 2025. As you can see, David Klee will be opening 2025 session, and there are a couple more exciting sessions coming up, including some engineers from Microsoft. And this is our biggest conference for data platform happening in November in Seattle. I'll be there in person. Today's speaker will be there in person. So check that out. And I have a code for you. You can use this code that will give you $150 off for a 3-day conference registration. And these are some of the events that happen around the world. These are a whole day conference, free of cost. Like the one I highlighted in blue, I'm being a little bit selfish here. I organized that one. That's happening next weekend in MTC Microsoft office in Burlington, Massachusetts. Also, it will be preceded by a pre-con by Bob Ward from Microsoft. So check that out if you're in New England area. But these are happening all over the country. So check out. I put some website links at the top. And we are in for a treat. We have Abdul from Microsoft, and I'm not going to read his bio, but he makes stuff happen, right? The stuff that we use, and he's going to tell us how we can use those things for less money. So I'm going to stop sharing and hand over. And just a few logistics. You cannot unmute your mic, and you cannot unmute, turn on your camera. So if you have a question, comments, put in the chat. I'm monitoring that, and I will be reading those to the speaker in due time. And the speaker also slotted some time at the end for discussions. So keep those questions coming, questions and comments. And I'll pass those. So Abdul, it's all yours.
Thank you, Taib. It's very nice to be here, and hello and welcome everybody. I'm assuming everybody is actually from the US. Can I get some thumbs up if you are not from US? If you are in some other time zone? Oh, we have Joachim. All right. At least one person outside of US. So I was going to say good afternoon. So it's not good afternoon for everybody. That's why I kept it hello. Let me share my screen. I met Taib in person at last pass here at Seattle at SQL Pass 2023, and Taib asked me if I'll be willing to come and talk to you guys about how to save some money when it comes to Azure SQL DB For most customers on any cloud, it's not just Azure, on any cloud, one of the biggest spend is on database. So being able to cut down the cost of database actually results in cutting down and all of the cloud bill because it's one of the largest spends for any cloud. Now, my name is Abdul Sathar. I manage the product management team for Azure SQL DB. Probably one of the best product management teams in any technology area. That's why we are able to roll out awesome products. I've been in the relational database technology area for a long time. Um, uh, Came to Microsoft about 5 years ago. Been in a few places before that, as you can see. That's about myself. That's my LinkedIn address. Please feel free to connect up with me on LinkedIn. I do some postings frequently about what is happening on our side, what we are working on, what is coming out. A good way to stay in touch. Now let's get started on cutting down the database cost or optimizing database cost. Just before going there, can I get a show of hands on how many people think cutting down their database cost will be of real benefit to the organization that you are working on? Oh, we have a few people. Now, the blueprint for cost optimization is kind of like, summarized in these 5 bullet points. One is categorize your databases based on criticality, scale, and performance needs. Choose the right Azure SQL DB service tier to fit the database category. So if you look at the SQL DB offerings that we have, you'll see it's like a wide variety of offerings. Sometimes we get actually into discussions with customers that you have just so many offerings. At some point, it gets so confusing. There is a reason why we have those many offerings. It is actually to fit the cost and technology profile of the customer. Some of the things that the customers are doing on-prem doesn't fit very well exactly how we are doing things on SQL DB. So that's why we have VM and MI. Some of the things that the customers are seeing from a cost profile from on-prem doesn't fit some of the offerings that we have in SQL DB. That's why we have like different tiers and different SKUs within SQL DB. So the more you know about these things, the better it aligns with your plan of cutting. So first, categorizing database based on the criticality, and then um, choosing the right Azure DB service, doing the right configuration, apply the fine tunings, and then of course avail all possible discounts. Like Tayyab mentioned, please feel free to shoot your questions in the chat. Tayyab will keep an eye on it. And if he needs to intervene, because certain questions are better asked while I'm talking about them, certain questions we'll keep for towards the end. Now, how do you categorize your databases? This is something that you guys have been doing for a very long time. I'm just reminding you how these things work. Most companies have tier one, tier two, tier three, and tier four plus production databases. Some of the production databases are extremely critical if you're a bank or a e-commerce company. The database that actually powers where your customers do transaction every second, every minute, that is highest tier database. And there are these kind of databases in every company. Then there are tier two databases that are probably customer facing as well, but maybe slightly less critical. Tier three databases, probably internal facing, maybe for your HR and payroll, or tax and financial reporting, whatnot. Then there are lower tiers depending on the departmental usage or whatever else that the company is doing. And then there's dev and test, and in test itself, there are so many different varieties of test environments. I have seen things like integration tests, performance tests, acceptance test. Then normally there is like a copy of production called gold, or something of that nature. So for many applications itself, there are 5, 6, 7 databases the customers would have. So make sure you categorize these database right, to pick the right tier of SQL DB service to get the best cost profile. So here's a quick look at what we normally recommend customers as the requirement for these database category that should keep in mind. If it is the tier one production database, you obviously want the highest performance. Then again, it depends on the business and what kind of business that you are in, what scale you are in. So relate all this to the business, the need that you have. So typically, this is how it goes. You would have highest performance for tier one. For dev test, it's probably the lower level of the performance. The usage is going to be 24/7 for tier one product, whereas for dev test, it's going to be, max 10 days, 10 hours a day, 5 days a week. And when it comes to testing environments, it's going to be even more infrequent, mostly on as needed basis, not, continuous. Database size also tend to fit in the same kind of pattern, where for your tier one production, you probably have the largest database. Where you go to tier three, tier four, they get smaller and smaller, and dev test, depending on what test environment it is, it could be pretty tiny. The scalability needs also are similar when it comes to dev test. Nobody really uses read scale. You don't really need multiple replicas. Whereas for tier one and tier two production, you probably want to isolate your writable primary from the read scale replicas that your customers can directly access to scale their reads. And depending on, sometimes just to scale reads, sometimes also to scale reads and control who has access to which instance of the database. And sometimes it's also for proximity to the user. So you could have your primary in one region and your secondary in a different region that you're replicating as a geo replica. So the customers from that secondary region, when they need to read, they could be routed to the nearest region, so the reads will be much quicker. Um, and this applies also to the disruption tolerance, or which we call RTO, or data loss tolerance, which we call RPO. Um, it is the highest that you need for tier one, and the RTO typically for tier ones cannot be more than seconds, and the RPO typically cannot be more than 0 data loss. Whereas for tier two, tier three, that can go up a little bit, low minutes, and a couple of minutes worth of data can be lost. Whereas for dev test, you don't care about data loss, because the data that you have probably is a copy or some part of a copy for production. You can replicate that anytime, and the database can be down for like an hour or more. As long as it comes back soon enough, that's typically good enough. This applies to the RPO and RTO, directly correlate to your geo-replication and zone redundancy. As you can see, when it comes to tier one and tier two, you need the highest level of resilience. So you probably need both of them, but as you go down the category, not as much. So like I said before, for this particular reason, we have many different tiers of service. Depending on what you're doing on the SQL side, it could be VM could be a better fit for you, or SQL managed instance might be a better fit for you. But most of our customers tend to use Azure SQL Database, as it is PaaS. It's a low touch, it's highly automated, extremely cost effective, and has a lot of features and capabilities the other two don't provide you. Now, these are, as you're aware, these are the service tiers that we have within Azure SQL DB. We have business critical and premium. Business critical and premium are very similar to each other. One is the billing is based on vCore. The other is a packaged offering, what we call DTU, where some additional things get like storage and backup gets added to the package itself. Whereas in business critical, you pay separately for compute and storage and backup and things like that. Gives you more flexibility. Then we have hyperscale, which is our flagship offering, which has been in production in GA for many years now, and it's growing faster than all the other services that we have for obvious reasons. I will go into a little bit more details of the architecture and how these things work in one of the future slides. We have hyperscale serverless, we have general purpose and standard, and we have general purpose serverless. Business critical and premium are, like I said, are architected in the same way. Business critical and premium uses the local storage in the node itself. So there is no need for the data to travel over the network, cutting down on all kinds of latency reduced by the network and the other layers in between. But when you have a single storage in a single node, the probability of failure and the probability of losing data is pretty high. So we have four-way replication there. Now, this four-way replication brings in 4 different nodes and the local storage in that node. And then we still are able to keep up the performance. But what happens with 4x the replication is the cost of the architecture goes up, because now your data has to be replicated 4 ways for resilience. And then because of the local storage usage, the amount of data that you can store in that node also has some limitations. So that limitation puts the cap as 4 terabytes for business critical and premium. You cannot have databases larger than 4 terabytes. But this gives us the best performance and lowest write latency because the data is stored in the local disk itself. Now, I just put some numbers in there for you to just keep your eyes on to see how these numbers change when you go from one tier to the other. For 2 vCores for business critical and premium, it costs about $1.59, $1.35 per hour, with a storage cost of 25 cents per gig per month. The second option that has been around for a very long time is general purpose and standard. Just like business critical and premium, general purpose and standard share the same architecture. Both use a single node primary and remote storage. Now, remote storage actually gives us the flexibility of using lower cost storage because the storage is not right there in the node, but then it comes at the penalty of lower performance. But using remote storage, if you know about Azure remote storage, the remote storage is 3-way replicated. Whenever you get a disk or like 10 gigs of storage, Azure storage actually stores it in 3 nodes as 30 gigs, 10, 10, 10 each. So there is resiliency at the storage level itself, which helps us not having to do replication or redundancy at the primary node level. That tremendously reduces the cost. Now we don't have to do the 4-way replication like we are doing in BC. Instead, we can use remote storage, and that cuts down the price. And then, as you can see, the cost, it goes down from $1.35, 36 to 50 cents an hour for the compute. That's almost like 60% reduction in cost. And then the storage goes down from 25 cents to about 11.5 cents. Then the other option is hyperscale, which is our newest offering and our probably the greatest offering so far. One common theme between the other 2 other 4 that I mentioned previously is it's not any different from how you could run SQL Server in your own data center. As being SQL Server people, I'm sure you have all set up always on availability groups and all kinds of configuration in your own data center. So if you look at GP or BC or premium or standard for that matter, um, they all follow the same architecture and same methodology as what you are able to do in your data center, except we have put a whole bunch of automation on top of it. There's virtualization, there is scalability, there's automation. All that actually helps us create the service at an extremely high scale that helps us reduce the cost as well. But again, the basic architecture remains the same as what you could do yourself. That is what completely changes in hyperscale. Now, I mentioned the max cap that you have in business critical is 4 TB uh, because it uses local storage, and then same thing on GP as well, though it doesn't use local storage. So it comes with some other constraints on how long it would take to restore a backup because it uses the regular SQL Server style backups. Now, as more and more customers, more and more workloads start coming to the cloud, the size requirements of the database these customers have keeps going up. And if you look at the cost profile for BC and GP, one other thing that you can see is we have constrained the amount of storage that you can have for a database in relation to the number of vCores that you will have to purchase. That is because if you think about business critical, if you buy a 2 vCore database and use 4 TB, you basically empty that whole node. We cannot use the rest of whatever 126 vCores available in that node because you took up all the storage. So because of that reason, we had to constrain the amount of data that you can store or amount of storage that you can use in that node in relation to the vCore. So you see, BC and GP has and standard and premium has some restrictions on what your database max database size can be for a given vCore profile. Now, this also is a little bit concerning for many customers who are running at cloud scale because they seem to generate a whole lot of data that is could be potentially used for analytics later on, but they want to capture all that data. But the amount of transactions that happen and the amount of CPU that is needed to power this database doesn't have to be like at the highest level available. So the in addition to the size of the database requirement going up for many customers, removing that correlation between the number of CPUs to be used and the storage data that can be stored also became an important concern. Now we went back to the drawing board and came up with an awesome architecture that is 100% cloud native that decouples the compute from storage. As you can see in this hyperscale architecture, um, there's the compute is completely separated from storage, and the storage also has multi-tiered storage. There is buffer pools that similar to the buffer pools in SQL Server or in BC and GP. Then there is RBPX, which is an extension of that buffer pool in the local storage of the node itself. Then there is page servers that are in local storage in nodes that are closer to the primary node. And then there is eventual, Azure storage that we are using underneath for, permanent persistence of this data. So you see, these are all decoupled, giving us and you a lot of latitude on what can be done with this architecture. Now, as a result of this really awesome architecture of a hyperscale, we are able to remove that constraints between the CPU and the storage. Now you can have a 2 vCore database with 100 TB of data. And right now, the max data size that you can have is 100 TB. That's compared to 4 TB of BC and GP. And we are already working on going even beyond that 100 TB in the near future. The other really cool thing that this architecture brings in is the ability to do horizontal scaling. In GP, that architecture doesn't allow any horizontal scaling, but in BC, because we are using always on, there are 4 replicas, as I told you, and one of those replicas are available for you to read from that you can use for read scale. Now, when it comes to hyperscale, that goes to insane proportions. You can have 4 HA replicas itself and up to 30 named replicas. Now, each one of those named replicas can have 4 HA replicas of their own. So that comes to a total of 30 times 4, that's 120 plus 4, 124 plus the primary. So you can have 124 replicas of your database plus the primary, giving you insane scale for read scalability and horizontal scalability. This decoupled architecture also allows to do instantaneous upgrades and downgrades and do like super fast backup, store, and restore. Because now if you think about BC, I told you it uses local storage. Because it uses local storage, if you are upgrading from, let's say, 8-week core that you're running now to suddenly 24-week core because your workload went up, and let's say we don't have any more CPU in that particular node to give you to upgrade you from 8-week core to 24-week core, then what we'll have to do is we'll have to move you to another node because now this node doesn't have enough CPU. Now, to move you to another node, we actually need to copy over the data. So if you have like 3 terabytes of data, it's a size of data operation. This upgrade is a size of data operation. You wouldn't really know much because we'll do this in the background. We'll move the data in the background and move you to the other node when the data copy is complete. But all this is completely different when it comes to hyperscale because the storage and compute is decoupled. We can keep all the storage level layers as it is, change the primary from now 8-week core to 24-week core in a matter of seconds. Now let's take a quick look at the cost comparison for production databases between these different tiers that I told you about. This is why I think it is extremely critical that you categorize your databases based on your database tier and pick the right service tier that we offer for the kind of database category that you have. Here I have tier 1 production. You see the business critical cost versus hyperscale cost. So in hyperscale, we have one differentiated SKU that we call memory optimized that gives you twice as much memory as the other regular hyperscale SKU. So for tier 1, I have used memory optimized, not the regular hyperscale. And for tier 2, I'm comparing the regular I'm comparing business critical with the regular hyperscale. And for tier 3, doing this for hyperscale and GP, and you can see the cost difference that shows up there. So business critical for tier 1 production costs $4,163. This for a sample 4-week core database with a 500 gig database size. Whereas for memory optimized hyperscale, that cost drops to $2,461. So that's almost like a 40% reduction in your cost. The same thing you can see happens for tier 2 as well. Substantial drop in cost. And this is still keeping everything else as it is, because it is tier 1, you are going to have a zone redundancy and a geo replica, and you have to pay for the geo replica and zone redundancy, all that as well. So if you look at the tier 1, because business critical comes with 4 replicas, there's no additional cost for zone redundancy. If you want zone redundant, we just put you in those replicas in 4 different or 4 different availability zones, and then it doesn't cost you anything. Whereas when you come to hyperscale, your primary is just a single node, And now if you want zone redundancy, you need to add another node on that'll go to a different zone and gives you that resilience at the zonal level. So as you can see here, picking the right database tier has a dramatic influence on your cost profile. So far, we talked about the different service tier that you have. Um, and now let's take a quick peek at the compute tiers that you have for these service tiers. Now, the service tiers I discussed was business critical, general purpose, and hyperscale. Of course, the business critical and general purpose have their DTU equivalent of standard and premium. Now, when you go to compute tier, we have so everything that I have talked about so far is about provisioned, where you pick a profile of the database, number of vCores with the corresponding memory, and stick to it. And as you know, we have another compute tier called serverless, where you wouldn't be paying the same no matter what your database is doing. So the serverless actually uh, helps you cut down your costs depending on the workload, depending on if the workload is going up and down, and what is the characteristic of the workload. If you look here, the database usage here, as you can see, is peak for a very short amount of time, and then it goes down, and it kind of like pretty stable for a long period of time, and then nothing happens for part of the time. Now, if you have databases like this, if you use regular provisioned, then you'll be paying the same vCore for all the time, no matter what you're doing with the database. In the new time and age, depending on what is happening on the cloud or what your customers are doing, there could be a lot of variability on how your database responds to it. So that is for production databases. But if you think about dev test databases, this could be a reality all the time. Customers coming and your devs coming and doing things probably from 8 a.m. to 6 p.m. And from 6 p.m. to next day, 7, 8 a.m., nothing much happens in there. And in addition to that, probably the usage goes way down during the lunch hours or early morning or late evening. But in the core productive hours, the usage spikes. Same thing happens with your test databases. The databases stay pretty calm most of the time, except when you're actually running it as load and it just peaks and goes up drastically. If you're using the provision model, you're going to be paying the same amount for the entire day for the entire month. If you instead switch to the serverless model that we have, where you have these kind of like peaks and valleys where your database goes up and down depending on what is happening in the database, you could substantially reduce your cost. Now, we had serverless available on GP for quite a while. It has been around, I think, for like over 5 years now in GA. And we have a lot of customers making use of GP serverless over this time. Many of these customers have moved their dev test databases to GP serverless to make use of pay only for what you use model. Now we have introduced the same thing for hyperscale. One difference between hyperscale and GP in this case, though, is hyperscale does not yet allows pause. In GP, when the database is not being used, it just goes to sleep, and it takes a little while to wake up once you send a query or try a connection. When I say a little while means a few seconds. Um, that is not yet available in hyperscale where the database goes to pause, but the scalability that I mentioned is still available in hyperscale as well, and that itself is makes a major difference to your cost profile, your bill, when it comes to the spiky workloads. Your database can go from 2 week core to 16 week cores or 4 week cores to 24 week cores in a matter of milliseconds, depending on what your database wants to do, and can come back to 2 week cores or 4 week cores all the way to half week core, depending on how low you want to go. So that way you are paying only based on what your workload requires, not the same thing all the time. Kind of like if you think about it, kind of like a difference between a Uber and leasing a car, I guess. I don't know how many of you know about it. If you know about, can you give me like a shout out? Raise your hand if you know about our database free offer. Couple of people. This is if you don't know about this, this is something you should know. You should recommend your customers, people who work with you, to go give it a shot. So we made an awesome offer available to everybody to go try out GP serverless, or just try out and actually keep the database forever. So you get a free database with up to 100,000 vCore seconds per month, with 32 gigs of storage and corresponding backup storage. No time limit. It's good for the lifetime of the subscription. So you can go try different things and feel the value that Azure SQL DB brings to the table, overall, and also try out serverless itself to see, how serverless can fit into the database landscape that you have. Now with this, let's take just like we did for production, let's take a quick look at the dev test database comparison. So I have hyperscale general purpose serverless, and hyperscale serverless. And you can see the cost profile at the very bottom. The reason I put another column there for hyperscale at 50% is because, like I said, showed in the architecture, the decoupled architecture of hyperscale actually takes a lot of weight off of the primary compute. If you look at general purpose does everything in the primary node, including the backup. So, when you have the backup service kick in and take a backup of your database, that actually takes away resources that are available for query processing in the database, because it happens in the same node. Whereas in hyperscale, because of the tiered architecture that we have, all those processes are like pushed to the storage side, making primary available only to do the compute work needed for query processing and data inserts and updates. So that means you now have a lot more compute capability or resources available on the primary side, and then it uses RBPX that's not available in GP. It uses page servers. It uses log replica. All that brings in a real boost to the performance of hyperscale compared to general purpose. And depending on your workload, your hyperscale performance could be more than twice or even better compared to the similar GP database that you have. Now, one thing that brings that to the equation is, now because the performance is so much better for hyperscale, probably you can cut down on your vCores that you're using for the similar general purpose instance and still be able to do what you want to do. So that's why I have the hyperscale at 50%. And you see the serverless is still works out to be cheaper than hyperscale 50%, depending on what you're doing on it. You can see a general purpose serverless and hyperscale serverless overall cost is pretty similar to 2014 versus 203, but that could change based on how long your database is in pause. If your database tend to pause more for longer and more often, general purpose serverless is going to be way cheaper than the hyperscale serverless, just because it doesn't have um, pause. I'll take a 1 minute pause here to see if there are any questions. Tayyab,
Yeah,
anything in
yeah.
chat?
So Ken asked a question. Is there a Microsoft Cloud certification that focuses on cloud cost strategies?
Uh, I'm sorry, I'm not really sure if there is one. What I'll do is, though, I will look it up and see if there is anything I can find, and reply back to the chat.
Yeah, I responded first. I said I'll ask you, but I said I doubt. But I found a Learn module that has multiple modules just on costing management. So there's like 5 or 6 modules that you can do. I put the link in the chat for everybody. So
Excellent. Right. Coming back to the presentation. Now, so far what we discussed is the ways to optimize the cost by picking the right tier of the service, depending on the category of the database that you have and what you're doing with that database. Now let's look at some other ways of optimizing cost. To be honest with you, one of the things that I have seen with a lot of our customers is many customers don't really pay a whole lot of attention to these things, and the non-optimal practices just keep adding more and more cost to their overall footprint, and it eventually reaches a point when it is really burdensome. That is when they realize, wow, our bill is so big, right? So if you do the right thing at the right time, that actually helps quite a bit to optimize the overall cost and keep the cost down. This is one of my favorite things in Azure SQL DB, the Elastic Pools. Um, no other cloud database provider has it, whether it is for the SQL offering on their cloud or any other offering, Oracle, PG, MySQL, whatever else. So this is a huge differentiator for Azure SQL DB, what we call Elastic Pools. Elastic, we have a good kind of analogy for elastic pools here, comparing elastic pools to single family homes versus hotel rental to a dome. So if you think about standalone DB, it is like a single family home. It's your own. You are there. You are paying the mortgage. You need to take care of it. All the costs accrue to you. Whereas standalone DB that is serverless is more like a rental or like a hotel room where you are going in only as you need. You go in there, you use the place, you rent a room for a day, or if it's in the airport, you might rent a room even for a few hours, and you are staying there only for that long, and you are paying the rent for that amount of time, and you don't do anything else. You are not responsible for the maintenance, the mortgage, the insurance, none of those things. All that is included in the rate for the hotel room. When it comes to elastic pools, it's more akin to a dome or a hostel or a room sharing. Now, in this kind of a setup where you could have a bunch of people using the same room, but not everybody needs at the same time. So think about having a roomie where the two of you are sharing a room, and one of you works in a regular job, the other one works night shifts. So you have the whole room to yourself when you need it, but it costs you only the half. Um, Elastic Pools is very similar, and actually going Elastic Pool way could cut down your costs by insane amounts, insane percentage, depending on what kind of usage profile your database has. And this is an absolute must have for any ISVs or SaaS providers where they have multiple databases belonging to many different customers that go up and down in usage continuously over the time of the day. And if you can figure out how that usage looks like, and if you can package them together, just like we talked about the dome, you can make tremendous savings. And when it comes to, we had Elastic Pools for a long time on general purpose. Now we have introduced Elastic Pools for hyperscale as well. So in general purpose, Elastic Pool had been a major hit with our very large customers. And on GP, you can have up to 500 databases in a single Elastic Pool. 500 databases. And on BC, you can have up to 100 databases in an Elastic pool. So when it comes to hyperscale, we started with 25 databases because of all the architecture complexity of hyperscale. Um, Currently, you can have 25 databases. That itself could help help cut down the cost significantly if you plan out in the right way. As I mentioned, one great thing about the Elastic Pool on hyperscale is, unlike GP and BC, here again there is no hard correlation between the number of databases that you can have in the Elastic Pool and the storage limit. And that's again a constraint that you would see we have in BC and GP because of the architecture that I mentioned before. You could have 500 databases only if you have substantial amount of vCores to support that many databases and the storage that is needed. But even with that, the savings that you could have are mind-boggling. So if you have this kind of workloads, if you haven't looked at Elastic Pools, I highly recommend you take a look at Elastic Pools and how Elastic Pools can save you money. Applies both on the hyperscale side and Elastic Pool side. I'm sorry, for non-hyperscale, that is GP and BC stuff. And now let's take a quick look at the backup storage cost. Backup storage cost, this is something that a lot of people tend to overlook. And over time, this kind of adds up quite a bit and becomes overwhelming for many customers. And depending on the configurations that you have chosen, this the backup storage cost could become 10 times more than your database storage cost itself. As you can see, for we have PITR and LTR. PITR for point in time restore, LTR for long term retention. For LTR, you could go up to 10 years of backup. And then for PITR, you can go up to 35 days of backup. That means you can restore to any point in time within those 35 days. And the long-term retention, you retain the full backup for up to 10 years, depending on the requirements of your industry, your business. Mostly these are done for legal purposes. Now, as you can see, there are many different options within each one of these. And depending on the option that you choose, your cost could be pretty high. Like if you look at RAGRS for a point in time restore, it costs you 20 cents per gig per month, whereas LRS costs you only 10 cents per gig per month. If you think about GP database, the data storage for GP is 11.5 cents, whereas the backup storage is 20 cents if you go with RAGRS. And RAGRS happens to be the default because we want to provide customer an automatic resilience against region failure. Now you don't have to go with this, or you might want to stick with this for your tier one production databases, but you change it for other databases. Maybe you can go with RAGRS for tier one production, but just ZRS is plenty enough for tier two, tier three, tier four. And LRS may be good enough for your dev test databases. And if you look at that, you can see how much cost savings this can accrue towards depending on the size of your databases and the number of the databases. We have many customers who are running hundreds of thousands of databases. Now, when you come to that scale, every penny matters because every database is going to have a backup. And if you don't plan well, all those backups could end up in the most expensive backup tier and could really run up your bill. Now, the same thing applies to long-term retention as well. The numbers are much smaller there, as you can see. LRS is only 2.5 cents, whereas RAGZRS is almost 8.5 cents. So if you look at the point in time restore, it's twice LRS and RAGR is twice as much as LRS. So if you look at LTR, it's the same thing for RAGRS, but if you happen to choose RAGZRS, it is even higher. It's almost like 3.5 times the LRS cost. But long-term retention, depending on what your corporate requirements are, you want to pick the right level of resiliency. So even if a zone goes down, even if a region goes down, your data survives. Now, when it comes to point-in-time restore, in addition to picking the right storage tier, it's also important to optimize how long the data is stored. As I told you, for Peter, you can store the data for up to 35 days, but you don't have to. If for dev instances, you never restore the data, you just refresh it from production, or yeah, you probably drop the dev database and restore from the data that was there yesterday. You don't need 35 days worth of backup. So probably you need 35 days backup only for tier one, tier two production. For the rest of them, you can go down, and for dev, you can have only 3 days. And all of this is going to make a huge difference in your cost profile. So thinking about some of the discounts that you can avail on your databases, um, you, I'm assuming you all know about Azure Hybrid benefit. Many of you have been SQL Server customers for a very long time, and your employers, your customers, um, probably own a whole bunch of SQL Server licenses, and you can bring those licenses to Azure SQL and get what we call AHAB discount, or AHB, or Azure Hybrid benefit. Um, if you look at the cost per vCore of BCGP, you'll see there is a AHAB discount, and there's a pay as you go price and the AHAB price. And AHAB price, what we do is we remove the license part of the cost from the pay as you go, and that gives you the corresponding discount and brings the price down. So some of the more cloud native offerings that we have, like serverless and DTU. DTU is premium and standard, and latest hyperscale, because there's no equivalent on-prem. This is purely cloud native. We do not offer AHAB, or the licenses that you own wouldn't make any difference in the pricing available to you. But if you look at the pricing, there's a huge price difference between BC and BC and hyperscale, because what we did with hyperscale is we completely removed the license part of it. As a cloud native offering, there is no license cost. It's only purely vCore hardware cost. There's no license cost involved. Now, when you bring hybrid benefit to the table, it's not just a pure discount that you are getting. You still have to pay for SA. What some customers do is they don't do long-term purchase of the licenses. They purchase licenses for 2 years at a time and bring that for AHAB benefit. That substantially reduces their overall cost if they are running on BC or GP. You can see the price difference right there on the screen. So if you for a 4-week or general purpose, pay as you go costs you a little over $1, where with AHAB benefit costs only 60 cents. That's 40% saving. Now you look at the same thing on the BC side, the savings are even higher. You get a 55% saving. So this is a great way to cut down your cost. But keep in mind, if you are using serverless or hyperscale, the AHAB discount doesn't apply. But even without AHAB discount, especially if you consider the SA cost that you have to pay per year, the hyperscale and serverless could end up still costing you less than either of these offerings. And then another great thing that's available is reserved capacity. Now, reserved capacity is available for general purpose and business critical and hyperscale. So you can, though AHAB is not available for hyperscale, reserved instance, or what we call RI, is available for hyperscale as well. So you can definitely make use of that in hyperscale. RI is not available for serverless because serverless is just paying for what you use, only for what you use. Um, there so far there is no model where you can actually reserve it for longer period of time. And as you can see here, the cost difference between the regular price and the reserve price, especially if it comes to a 3 year reserve capacity, could be substantial. And now you pair that with ahab discount, and it's in a completely different level. So if you look at the business critical on the right hand side of the slide, for 4 week course, if you are using pay as you go, it's going to cost you $2.71 or 72 cents per hour. The same thing if you go with reserved capacity and ahab, 3 year reserve capacity, and ahab, it's going to cost you only 55 cents. That's an 80% discount. um, so these things can have a major impact on how much you're paying for the database, the overall your cost profile and overall footprint on Azure SQL DB. Like I said, just to reiterate, categorize your database, pick the right tier, um, use ahab if you can, use reserved instance, and always consider hyperscale and serverless if that fits your workload type. So finally, a quick cost comparison with hybrid benefit, which is ahab, and the reserved capacity discounts. So I just bring the third or fourth slide that I discussed before. I brought it back here with every possible discount, and take a look at the overall cost for tier one production with ahab and reserved instance discount. Your business critical cost now went way down. It comes to 1,039 versus memory optimized hyperscales 1,139. It's kind of like very similar now. Actually, memory optimized hyperscale is $100 more than business critical. But if you go for regular hyperscale, the cost will drop further. If you go to tier two, as you can see, the BC remains the same, but we went to the regular hyperscale. So now hyperscale is slightly cheaper than business critical. So depending on if you can avail all these discounts on the business critical side, which is ahab and reserved capacity discount, and your data size profile, it comfortably fits within business critical. Maybe business critical is a better fit than hyperscale. So many things to look at to see what is the best fit for you from a usage perspective and cost perspective. Now, if you don't have ahab or you cannot use 3 year RI, that's a completely different equation. Hyperscale will always come out winning, uh, no matter which way you cut it. Now, when you look at the dev test, hyperscale versus general purpose versus hyperscale at 50% that I mentioned before, or general purpose and hyperscale serverless, you see hyperscale at 50%, even provisioned, actually comes out the winner most of the time. But depending on the usage profile of the database, especially if it is dev test, serverless is going to be way better, way cheaper, especially general purpose servers. So one takeaway from this whole discussion is, in most cases, hyperscale comes out as the winner when to reduce costs. So definitely always take a look at hyperscale and serverless, depending on the workload that you have, the database that you have. I was planning to give 10 minutes for Q&A. Unfortunately, I ran over. So we have only 2 minutes left. I can actually stick around for a few more minutes if there are questions.
Thank you very much. Very helpful. Um, I mean, I don't know about others, but money is tight, right? Everybody knows. So it was very helpful. And no, there are no further questions. Someone asked for the YouTube recording. I gave it. But folks, if you have any further question or comments, you can put in the chat. I will wait for a few seconds. If not, we'll close it. But thank you again, Abdul, for coming. And I know how busy you are, and and giving us this 1 hour. I think, yeah.
It's always a pleasure talking to our users and customers. And you've been part of the SQL Server community for a very, very long time. So no better people to talk to.
Uh, are there any third-party tools you recommend for tracking cloud costs?
Um, um, Azure itself has a bunch of budgeting tools and tracking tools that probably is the first place to look at. Yes, there are a bunch of third-party tools available as well. Datadog is a great one. They have a lot of excellent tools available for cost tracking and cost optimization. IBM has one, I think it's called Guardium, that's pretty heavily used. There are a whole bunch of these kind of tools available in the market. But Azure has a bunch of free tools that'll actually help you optimize your cost. That you should look at that first.
Okay, so there are no other questions. So thank you
Well,
very much. I'm going to stop the recording and we'll. Oh, sorry, Khaled Candle. Azure Cost Management Creating Budgets. Azure has a new change analysis tool to see where update, create, and deletes are happening. Oh, so that's probably a comment. Okay, thank you.
yeah.
Yeah.
Thank you so much. It was a pleasure. Being in the middle of you